Good morning, everybody. Today we are talking about the optimization of production processes and industrial digitalization, with a focus on small and medium-sized enterprises. So I would start with some of the challenges that production systems are facing today. One of them is more complex products. These products also have shorter product life cycles. Then we have significantly fluctuating demand throughout the year. There is also a tendency towards smaller batch sizes. More specifically, production systems are trying to move towards one-piece flow production systems. Then we have supply chain instability, such as different disruptions of supply chains around the world now because of wars, the situation in the shipping industry, and so on. There is also a tendency of labor shortages. And finally, there is constant sustainability pressure, meaning how to make production systems even more environmentally friendly or environmentally sustainable. So, to address these challenges, companies need to implement different technologies. These are mostly technologies that are trying to transform the system and make it more agile. And these more agile systems require a more skilled workforce. That also requires a good balance between cost, efficiency, and sustainability. This is a great challenge, particularly for small and medium-sized enterprises, because they usually do not have enough resources to educate themselves, research, and analyze what kind of technology would be the most suitable for them, and in which way to adapt that technology. So most SMEs come to this challenge by trying to adapt themselves to the technology, instead of trying to find a technology that will really suit them and support their processes. One of the technologies that is currently among the top technologies on the market for optimization of production systems is digital twins. This is, I would say, not a completely new technology, but it is also not a completely market-mature technology. Today, mainly, very big players on the market are using it on a daily basis. However, this is something that small and medium-sized companies should look up to in the future and should try to reach in the close future, maybe in 3 to 5 years, if they want to stay on the market. So what does this digital twin represent? It represents a technology that enables companies to create completely virtual production systems that mirror their existing real production systems. All the changes and challenges they have in the real system can first be analyzed, tested, and optimized in the virtual environment, without jeopardizing worker safety and without spending too much money on technology before they test it. So it also comes down to test before you invest. They can really use these digital twins to change and examine different changes within the production system before making a real decision. At the same time, they can make decisions based on real-time information, precise information, and at the exact moment when the decision is needed. To eventually reach a digital twin, a company should first start with a simulation of its production system. Later, this simulation should be connected with software tools called manufacturing execution systems, or MES, which provide the simulation model with real-time data. Ultimately, we want to have a real system operating, and a digital version of that system operating at the same time, exchanging information in real time. So in order to reach this kind of complex production, optimization, and management system, the first step is to start by using material flow simulation to create a simulation model of the existing production and logistics system. This digital representation is first used by companies to understand how their system works, where the bottlenecks are, what the real challenges are, and how they can deal with different changes on the market and in the production system. Then they can test how their system would work in different scenarios. However, in this first step, when we create a digital model, we need to manually add inputs in order to have any analysis available for decision-making. This means that we manually input parameters into the system and then analyze statistically how the system behaves according to the parameters we put into it. When we want to bring this system to a higher level, we need to create a system that automatically takes information from the real system. For that, we need some kind of devices set up in the production system that send information in real time and feed our digital model with real-time data. At that point, we already have something that is called a digital shadow, so we upgrade our simulation model into a digital shadow once the digital shadow works well, and once we can use it to monitor how the system works based on real-time data. Then we need to add additional technology that sends information from the digital model back to the real system. Then we create this loop interaction between the real system and the digital system. And that is when we really have a digital twin. Because this can be very challenging, it has to be developed step by step. Now, we will start from the very beginning. How these simulation models are created, why they are created, how they look, and what they can help you with. The first step towards this kind of digital transformation is to create a simulation model. This simulation model represents a digital representation of the real system. It can be used for production, logistics, or service-providing systems, so it can be applied in different kinds of industries. It can also be used for strategic, tactical, and operational planning of the system. It can be used for planning new systems or for optimizing existing ones. That means you can create a simulation model of a production system that you already have. Or you can create a simulation model of a new production line that you plan to implement in the next 1 or 2 years. The biggest advantage of these simulation models is that they answer the question, what will happen if? This means that I can change a parameter in the simulation model and speed up the simulation process in 1 or 2 minutes. I can see what will happen with the system after 8 hours, 1 day, or 1 week, so I can evaluate how the changes I make now will influence my system in a couple of hours, or a couple of days. That gives me a time advantage and helps me make better decisions, because I can already see how different decisions can influence my system. Simulation can also help us prepare for extreme changes on the market. For example, what happens if demand increases by 30%? Or if something changes and demand decreases by 20%? So I can test my production system in different scenarios. Based on the simulation results, I can decide what backup plans I need to create in my production system in order to reduce the risk of problems on the market and to increase my performance. When I use simulation for new systems, the first thing I can use it for is the visualization of the conceptual solution. This means that you already have a plan of how your production system should look. But with the simulation model, you can really see how the system will look and whether you planned it correctly or whether some changes should be made. Then you can optimize the layout. You can reduce the required space, set the machines in the right order, reduce the length of material flow, and optimize the system before you even start building it. Simulation can also be used to compare different technologies. For example, if you have a production line and you want to decide which packing technology would be the most suitable, you can test 2 or 3 technologies using simulation. Then the simulation results can help you decide which technology will be the most suitable in the next year, 3 years, 5 years, and so on. It can also help you optimize the number of employees. This means that for the level of efficiency you want to achieve, you can determine the exact number of employees you need. And not only the total number of employees, but also the specific type of qualifications needed for this kind of production system to work. So you can know, for example, that you need 5 engineers, 10 operators, 20 people in logistics, and so on. Based on all this analysis, you can also create a very good basis for a realistic determination of return on investment. Based on the simulation results, you can see how long it will take for your system to pay back the investment required to set it up. There are different software tools that can be used for creating this kind of simulation model. One of the most present and one of the best on the market is Technomatic's Plant Simulation, offered by Siemens. This software helps you create a digital representation of any production or logistics system. To analyze it, I will now open the software so that you can see with your own eyes how simulation models in this kind of system look. Here, I have an example of a simulation model. You can see that I can really work with this model. I can zoom in, zoom out, and see every specific element in the system. One of the key advantages of having this kind of simulation model for a production system is the remote controller, where I can speed up the simulation. For example, if I reduce the speed, the system starts and everything moves in real time. However, I can also speed up the process. And then the simulation runs much faster. I can let the simulation run for a couple of minutes. In less than 1 minute, the system simulated more than 52 minutes of work. So, in less than 1 minute, I can see what happens with the system in 1 hour. Now I can really see how each element of the system works. I can introduce different charts where I can see the efficiency of each element. I can enter each machine and see the efficiency of that machine. I can see how much it is working, how long it is waiting, whether the material flow on this machine is blocked for any reason, how many pieces were produced during that time, what the average processing time was for each piece, and so on. So I can really go deep into the system and analyze many details. For each worker, I can see their efficiency, and even how much distance they walked during a specific time. I can also see the pathways that workers used and where the highest density areas are. This can help me with layout planning. I can also see the flow of material, where the highest density of material flow is, and so on. So this can really help me understand how the system works. I can then enter the system and change the parameters of each element. For example, if this machine was working with a processing time of 13 seconds, I can ask, what will happen if I change this from 13 seconds to 20 seconds? Then I repeat the simulation, and I can see the influence of changing any parameter in the system. I can see whether it increases or reduces my efficiency. I can also set that the machine has certain failures, or that repairing these failures can last for 20, 30, or 40 minutes. Then I can see the influence of each of these failures on the system, and how the failure of one machine influences the material flow through the entire production system. So these are some of the key advantages of simulation models. This is something that has become very present on the market and very affordable. Even in Serbia, there are now many small and medium-sized companies that use simulation models to understand their systems, analyze them, and plan new production systems. So this is not really a technology that is out of reach for small and medium-sized companies. It is very present, available, and affordable. The challenge is that the simulation models should be created by professionals who are very familiar with the technology and who can create models that really provide quality information. The biggest challenge with this kind of model is that if you put garbage information in, you get garbage out. That means that when defining the parameters of this kind of system, such as the frequency of truck arrivals, the processing time of each machine, the number of workers, their skills, the layout of the production system, and so on. You need quality input information in order to get useful results. If you use imprecise information, then the results cannot really be reliable. This brings us to our next topic for today. In order to fill this kind of simulation model with precise and relevant data, the best option is to use a system that provides real-time insight into how your machines and your system are working. These systems, used for real-time monitoring and management of production systems, are called manufacturing execution systems, or MES systems. Today I will show you an example of a MES system. It is called DigiPro MES. DigiPro MES is a solution developed by a startup company in Serbia, and experts from our faculty also participated in the development of this solution. I am showing it to you today because it is software dedicated to small and medium-sized companies. It is available on the market at a price that is affordable for SMEs. So you can see that this kind of system is available even for companies with 10, 100, or 300 employees. So, how does this DigiPro MES solution work? It takes work orders from the ERP system and then generates specific work orders for each activity in the production system. For example, T creates a work order for the tool shop to prepare the tool that should be set on the machine. It also sends a work order to the logistics department to prepare the material for a specific product and bring it to the right machine at the right time. It also provides a work order for the employee, for example, to come to the machine, set the tool, and start production of a specific product. The hardware is installed directly on the machines and collects data about machine cycles and production activity. It works independently from the machine's internal control system, so it can be used on different types of machines, from different producers, and on machines of different ages. The hardware collects real-time data from the shop floor and sends it to the software system for monitoring, analysis, and work order tracking. Now I will briefly show how the software works in practice. This is a real-time overview of a production system in one SME in Kakak, Serbia. Here we can see the machines, active work orders, production status, cycle time, number of produced pieces, and current machine activity. By entering each work order, we can see all related activities, delays, quality controls, responsible operators, and how long each action took. This gives management a clear overview of what is happening on the shop floor in real time and helps them identify delays, labor shortages, machine issues, and opportunities for improvement. The software also includes AI-supported analysis. So it can answer questions such as which operator was the most efficient or which machine had the longest delay. Let me now explain you in more detail how the system works. Through the application, the operator receives all important information. What needs to be done, on which machine, what the problem is, and what the current status is. The application also includes a knowledge base with work instructions, standardized procedures, videos, and problem-solving materials. This helps operators solve problems independently, even during night shifts or when more experienced colleagues are not available. A good example, or a good practice case study, is the company you saw on the screen, where this system is implemented. This is a company that we as a faculty worked with. They had certain challenges. They produce plastic bottles and boxes for the pharmaceutical industry. During the COVID period, their demand increased by 80% in 1 year. Because of that, they had to find a way to use their capacities in the best possible way. So they hired us to create a simulation model for them. You can see part of this simulation model on the screen. The simulation model was very useful. However, when we started testing different scenarios, we understood that we were missing a lot of real-time information. This information was needed to feed the system and enable them to make good and responsible decisions in real time. That is why they decided to implement the DigiPro ME system. DigiPro MES was implemented and started sending them real-time information. We integrated the simulation model with the inputs from the DigiPro system. Now they have a kind of digital shadow that they use for production planning and decision-making. This significantly improved their system. One of the most important indicators is that when they started working with us and when we created the simulation model, they had around 50 employees. Now they have 80. So in about 2 years, they almost doubled their capacities. They also increased the number of machines and the number of people, and they more than doubled their yearly income by applying these technologies. I would say that these systems really optimized their production and increased their efficiency. The return on investment for these two systems was less than 1 year. That would be all from my side today. If you have any questions, I would be happy to answer them.